So in section 7.5, we're going to take a look at multiplying and dividing radical expressions. Specifically, really, we'll look at multiplying them, and then as far as dividing is concerned, we'll look at this phrase called rationalizing denominators, some simple cases of that. So when multiplying, and this is kind of just recalling our rules, to multiply radicals, all they need is the same index. So the same kind of root, square root, cube root, etc. But when we go back to combining them, adding or subtracting them, that's where we have that rule of same index and radicand, right? Index and inside. So definitely keep those rules separate. And a reminder, something as simple as this guy can be very confusing. Don't allow yourself to simply add those two numbers if it looks convenient to do so, because again, that's following this rule here. If this is a square root of 2 term, if this is not a square root of 2 term, you cannot combine them, right? Cannot be added or subtracted. So just keep that stuff in mind as we're going through here. All right, so the first example, got root 2 times root 18 minus 3. The idea of whether you want to simplify before or after is really up to you. There's no wrong way. I generally think multiply first, simplify at the end, but there might be cases where that's not even the simplest approach. So in this case, if we multiply, we're really just distributing. Square root of 2 times square root of 18, I can do because they're both square roots, and I get square root of 36. Here, it's just a square root times a number out front, so I would just call that minus 3 root 2, right? We're allowed to do that. Now, as far as simplifying is concerned, notice here's a place where it almost was better we didn't bother simplifying at first, because by multiplying these, I get the square root of 36, and although neither of these was a nice perfect square root, 36 is, that turns to a 6, very conveniently. That doesn't simplify at all. And again, this would be a place where you don't want to be tempted. Do not do 6 minus 3. These are not like terms. They cannot be combined. So we stop there. All right, the next one. Just like if these were binomials involving variables, we will distribute every term in the first, every term in the second. 6 root 5 minus 6 root 7. Now I distribute these. They are square roots, so they can multiply. 2 and 5 will give me root 10. 2 and 7 will give me, minus a square root of 14. Now we would look at each of these radicals and look for anything to simplify, but none of them break down, right? None of them even have a pair of factors in common. So if they don't simplify, and none of them match index and inside, then they're not going to get combined. So that's it. That's our result. All right, next one. This is the one we got to make sure we remember. Don't fall for the very common mistake of just squaring each piece. Make sure we remember squaring a binomial, write it out. Think about what that means. It means this times itself. Because now you draw arcs and see what happens. Now, let's talk about this. Square root of 5 times square root of 5 would be a square root of 25, right? We can do that. Square roots can multiply. We'll come back to that in a second. Square root of 5 times a negative 2 would give me that. Then here's another one, which will give me another, and negative 2 and negative 2 for a positive 4. Now here, square root of 25 works out nicely. Let's not miss that. That's a 5. And as I write that, let's also point out this right here, a square root times itself, square root times square root, when they're the exact same thing. Notice we got what was inside. It's basically because of the definition of a square root, right? When I say this is a square root of 5, by definition, this is the thing that if you squared it, you get 5. That is how we interpret, how we understand a square root. So when you square a square root, you get what's inside, right? That should make sense. And we're going to see that a lot. In fact, we're going to see this even on the next page as well. Very, very useful. On the next pages, I should say. So that turns out to a 5. Here, notice, these are like terms that we can combine because they're both square root of 5. Square root of 5. That was our rule. Same index and radicand, meaning we can combine the outsides and get a negative 4. Square root of 5. Again, don't change what made them like terms. I'll bring down the 4, and then now that we've simplified that, a little more like terms can be combined to give me a 9 and a minus 4 square root of 5. All right, next one. Again, we'll do the distributing. Distribute that 3, gives me 9 minus 3 root 2. Distribute the root 2. Notice that'll give me a positive 3 root 2. And then this guy here, I'll go ahead and write it out again. It's a Positive times negative is a minus. Square root of 2 times square root of 2 is a square root of 4. But again, watch what happens here. I'll bring down the 9. Now here we've got a minus 3 root 2 and plus 3 root 2. So again, the root 2, square root of 2 makes them like terms. Minus 3 plus 3, though, takes each other out. That's 0. Like, they're gone. And then over here, the square root of 4 reduces very nicely to a 2, meaning our final answer for that is a 7. And again, just to point out, this was square root of 2 times square root of 2, and we got a 2, right? You squared a square root, and you got what was inside. Keep that in mind. Now we're looking at cube roots, so that's not going to happen, right? This neat thing here won't happen with cube roots. We need 3 of a kind for a cube root. So let's look at this one. Distributing the 3 first gives me 3 times 3, which is 9, and then 3 times the cube root of 2, so minus 3 cube root of 2. Now I'll distribute this one. Here's going to be a positive 3 cube root of 2, and here this will be a minus cube root 2 times cube root 2. I'm allowed to multiply them because they're cube roots, but to multiply them, 2 and 2 give me a cube root of 4. So again, indices matched so you can multiply the insides. We look at what's left here. I'll bring down the 9. Cube root 2 and cube root 2, those are like terms, but minus 3 and plus 3 take each other out again. And here, this does not simplify. A cubed root of 4 will not simplify, right? 4 is just 2 times 2. There's not 3 factors there. So this would be as far as we can go with that one. And just to point out, these last 2 examples with these middle terms canceling, why has that happened both times? Because the pattern that we started with was what we called the product of the sum and difference of 2 terms, right? Both had 3's and root 2's. One was a plus and one was a minus. Both had 3's and cube root 2's, but one was a plus and one was a minus. This is a very specific pattern of a plus b times a minus b that we've seen before. That's why these middle terms are canceling so conveniently like that. All right, and the last one, we've got a binomial times a trinomial, so just more arcs for more terms. Drawing the 2, distribute to everything first. 2 times 4 is 8. That'll be a negative cube root 2, and then it'll be a 2 cube root 4. Then take the cube root of 2 to everything. Cube root of 2 times 4 will be 4 cube root 2. Here's a cube root 2 times a negative cube root 2. They're both cube roots, so we can multiply them. 2 times 2 is 4. Positive times negative was a negative, so negative cube root of 4. And the last arc, cube root 2 times cube root 4. Again, both cube roots. So 2 times 4 will give me cube root of 8. Now, from there, what can we do? Well, we can bring down the 8, took care of him. Here is a cube root of 2 term, and there's another cube root of 2 term. Those are like terms because they have the exact same index and inside, right? So now that we're talking about combining like terms, negative 2 and positive 4 will give me plus 2 cube root 2. Now, on to this cube root of 4 term, which we've got another over here. Cube root of 4 and cube root of 4, that's a positive 2, that's a minus 1, so just plus a 1 cube root of 4. And then this is the only cube root of 8 term, but cube root of 8, that works out nicely, conveniently, to a 2, which means now we have a little bit more in the like terms category. We can combine those 2 values, and then that right there would be our fully simplified answer. So that was some multiplication. Now, like I said, for division, we won't really actually do division, but we will focus on a rule or idea that we mentioned earlier, which was earlier in the chapter, which was that we don't like radicals in denominators, okay, for final answers. So there's a very simple approach, and it can vary depending on exactly what you're looking at. In this class, we're going to stick with just square roots, single terms in the denominator. So use that trick we saw multiple times here earlier in this section. This is the square root of 3. I want to do something to this fraction where I don't change its value, but I change what it looks like. So basically that amounts to doing the same thing to the top as I do to the bottom to keep it balanced and keep it the same. The question is, what would I want to do? What could I do to this denominator that I could also do to the numerator that would make it to where there's no radical down here. And before we say squared, you cannot square this and square this. That would not be the same thing. If I square this, I'm multiplying by root 3. If I square this, I'm multiplying by root 10. That's not the same thing top and bottom. But what we just said there is important. To square this would be good. If you could square this, this would be root 3 times root 3, which would be a 3. So rather than thinking about it as squaring it, think about it as multiplying it by itself, right? That times itself is going to work out for us to get the denominator to not have a radical. And if I'm multiplying the denominator by that root 3, just simply multiply the numerator by the same root 3. Do the same thing top and bottom. Up here, root 10 times root 3, we can multiply those and get root 30. Down here, square root of 3 times square root of 3 is just 3. That's what we're trying to do. We want just a number. We don't want any radical down there. Now, you do want to make sure that this can't be simplified at all. 30, to break that apart, is 3 and 10 and 2 and 5. So 2, 3, and 5. Doesn't look like we can reduce or simplify that 30 at all. So we won't. So we won't simplify this, which means that's done. But that's it. You're doing the same thing to numerator and denominator that would help you get rid of that radical. So same thing here. We've got our root 7. So to get rid of it, we will multiply by root 7 on top and bottom. Up top, we just get negative 56 root 7. And on bottom, the reason we did this, square root times square root gives you what's inside. Now here, pay attention to the fact that those numbers on the outside can reduce, can simplify. Right? We don't simplify inside, but we can cancel these outsides, and we can say 56 over 7 would be a negative 8. So negative 8 root 7. And then lastly, we got a fraction, the whole fraction inside the square root. So remember, the first thing we can do here is we can break that apart. We learned that we can separate our radicals like that. While we're at it, let's go ahead and point out that this, actually we don't need to. We can just go straight to the rationalizing. We can say we don't like that square root of s in the denominator. So let's do that. Multiply both top and bottom by that specific square root. So up top, we now get a square root of 75 r cubed s. That just kind of works itself inside there. This comes out as just an s. Don't confuse that with a 5. But now look at the inside of this radical, and we can simplify. First of all, 75 breaks down to 3 and 25 and 5 and 5. So if that's 75, a square root would mean that 5 could come out, and the 3 would be left inside. I left a little room here because we also have an r cubed. Square root of r cubed, you want a pair of r's. Well, there's a pair of r's in there to come out as a single r. So you pull 2 of them out for 1 r, and there's 1 r left over inside along with that 1 s. So we get 5r times the square root of 3rs over s. Again, don't confuse that with a 5. And so in this case, nothing out here cancels. So that would be our final answer.